imagine you're walking through a bustling airport. You move seamlessly through security without the need to present your ID or your boarding pass. Cameras discreetly scan the crowd, effortlessly identifying each individual based on their unique walking pattern. No, this is not a scene from a futuristic movie. It's a potential reality with gait recognition technology. So what is gait recognition, right? So at its core, gait recognition is a biometric technology that analyzes the unique way in which an individual walks to verify their identity. Right? So unlike conventional biometrics like fingerprint or facial recognition, gait recognition leverages the distinctive patterns in a person's stride, posture, and movement, right? So these patterns are influenced by various factors, such as the structure of the skeleton, your muscle strength, and even habitual behaviors that are formed over time. So here you can see gait recognition being performed in real time and how it's analyzed. So gait recognition can really be broken down into 5 steps. So you have your gait capture step, contour detection, silhouette segmentation, and finally you have feature extraction and classification. So gait can be captured using video cameras or even wearable sensors. Another method of capturing gait involves the use of radar to remotely identify moving objects. So what happens in that scenario is radio waves are directed towards the object of interest, then reflects off the body, and then the system then recognizes these reflected waves and utilizes this data for identification purposes. So silhouette segmentation is suitable mainly for applications that use video camera recordings, right? So a binary image of the person's silhouette is extracted from the recording and analyzed by vision-based algorithms. So silhouette segmentation basically simplifies the algorithm's task of processing and mapping more comprehensive image by only isolating the useful data from that image. Right, so next up, the system will delineate the boundaries of the human body by highlighting just the contours. So the methods to employ this or to achieve this is vary on the hardware that's used. So whether you using cameras or wearable sensors, this differs. So next up, the individual features of gait are extracted, such as joint movement, limb angle, stride, as well as your cadence. So there's up to 24 unique features of gait that can be extracted at every stage of gait. So a convolutional neural network is often used to extract these features. It's primarily because these models can automatically learn to identify and encode these complex patterns from given input data. So the final and probably most exciting step is the gait data is then stored in a database for later reference and model training as well. Right? So a classifier model, which more often than not leverages a powerful machine learning algorithm, then compares the new gait signatures with the stored signatures in the database to then find a match. So this can be done using techniques such as nearest neighbor, or even more complex similarity measures can be used, right? So the primary determinant of gait is the size of the human skeleton. Terrain also plays a role. It can change the speed at which a person walks. So injuries in footwear can be significant as well. So if a person walks barefoot, their gait actually changes. If a person has been injured, the effect on gait can sometimes be unpredictable. So in addition to all of this, the system also needs to analyze the development of the person's muscles and how tired they are. And so the most obvious application of gait is security and surveillance in public spaces such as airports, train stations, stadiums. But gait recognition can actually extend far beyond these applications, right? For example, in nursing homes, it can alert staff if a patient falls, or in hospitals, the system aids in diagnosing neurological disorders such as cerebral palsy. So these patients, the study of gait leads to a much more thorough diagnosis and actually assists in the rehabilitation process. So aside from clinical applications, gait analysis is also used in professional sports to optimize your gait and improve your overall athletic performance. So these are all real-world examples, right? But what about the accuracy? So researchers at the University of Manchester have actually developed an AI-powered gait recognition system called SFootBD, which contains around 20,000 footstep signals, right, from 127 different individuals. The system uses a pressure plate and high-resolution cameras as well, combined with an AI model that takes into account around 24 different factors and movements when walking. So together, the system actually achieved a crazy accuracy of 99.3%. So what are the advantages of using gait recognition over biometrics? So gait recognition is inherently non-intrusive. So unlike fingerprinting or retinal scans, it does not require physical contact or even close proximity, which makes it much less invasive and more user-friendly. It's also really difficult to mimic. So while facial expressions can be altered, fingerprints can be obscured, an individual's gait is much harder to disguise or even replicate. So while the this technology, sounds great, it does have a few limitations. So it requires special sensing panels or high resolution cameras sometimes, which obviously aren't cost effective. The system also can only recognize individuals whose data have been pre-recorded and stored in the database, which limits its current applications. So in other words, the system is only as good as the database that runs it, right? So there are also some ethical considerations, such as the collection and storage of gait data. It raises privacy concerns, right? So before a system like this can even be put in place in real life, it's crucial to first establish some robust data protection methods to safeguard the user data. So additionally, your individuals should also be informed and give prior consent before the gait data is collected. So gait recognition represents a significant advancement in biometric technology, with the power to enhance, security, improve healthcare, and offer conveniences to our daily lives. However, it is important to ensure that the collection and storage of gait data is done ethically. Thanks. Any questions?